So welcome everybody to today's IEEE EMC Society meeting. Southeastern Michigan EMC Chapter 27 is the main sponsor of the meeting. We also invited several other chapters to our meeting. We have Cedar Rapids, Milwaukee, Central Texas, Coastal Los Angeles, and Western Michigan. So I can't really tell from here what chapter you're in, but I'm assuming we have kind of a mix. We did have 76 people sign up, so we'll be taking attendance as the meeting goes on. So as I mentioned a minute ago, if you don't have your real name up, please mouse over your name on the screen on the matrix there. There's 3 dots in the upper right hand corner. Pick rename and put in your name so we can do attendance for IEEE. And also please mute yourself at this time. You can leave your camera on or off when the meeting starts. It's up to you. Tonight's meeting is sponsored by the Southeastern Michigan IEEE EMC chapter. We don't have a corporate sponsor this evening, but we are still going to do the door prizes, but you must be present to win. So after the meeting, we'll be doing a random number selection versus the roster. The first prize will be a $75 gift card from Amazon. Second prize is $50 gift card, and third prize will be a $25 gift card from Amazon. And again, you must be present to win, so please stay for the meeting. I do have one announcement. If anybody's looking for a summer interns for electrical engineer, I have actually have a resume here. If you message me, I can send you the resume. He's a student. He went to U of M Flint for 2 years, and now he's at the University of Michigan, Ann Arbor, and he's majoring in electrical engineering. So he's looking for a summer internship. So please, you can send me a message, email or private message me or whatever you like, or message me through this meeting. I'll send you the resume for him. Also, as I mentioned a couple minutes ago, EMC Fest 2022 now, it was 2020 originally, is currently scheduled for May the 12th at Livonia. So we'll be sending out information soon on that. So our speaker tonight is Arnie Nielsen, and before we go on with him, we have I'd like to read this letter from our awards chair. Dear Arnie, on behalf of the Southeastern Michigan IEEE EMC Society, I wish to express appreciation for your presentation to our chapter on January the 20th, 2022, entitled Application of Thrifty Test Equipment for EMC Tests. The chapter has recognized your professional commitment to the education of our members with a speaker award, which includes a donation in your name of $100 to the IEEE EMC Society President's Memorial Scholarship Fund. Your name, topic, presentation, donation may be viewed on the chapter's speaker award list page on our website, which is www.emcsociety.org. And there you can also see a complete list of our speaker awards since 2012. And I'll be sending you an electronic copy of this letter, Arnie.
Thank you.
So this evening's presentation is by Arnie Nielsen. Arnie has decades of experience in the automotive electronics industry. He worked as an instrumentation engineer in the crash test facilities at Chrysler and Ford, followed by powertrain, engine and transmission, hardware and software design at Ford. From 1985 to 2005, he worked in EMC, reliability, and product assurance as a senior technical specialist with Ford Visteon. After retiring in 2005, he's been consulting on a wide variety of products under Arnie Nielsen Consulting LLC. Arnie is an INARTE certified master EMC design engineer. Now I'll turn it over to you now, Arnie.
Thanks, Scott. Okay. There you see my mugshot in Florence, Italy. I look relaxed there. That's why I used it. This was actually a lot of fun putting this together, and I have to give my wife credit. She came up with the word thrifty. Thought that was kind of catchy. Okay, introduction. You can pretty well read what I have there. Basically, we're looking for really low cost ways to check fixes before and after, because these labs are so tied up, they're expensive. I don't know how anybody would spend the time required to fix some of these problems, because I work on them for sometimes weeks, many weeks to fix some of them. I don't know how you do that in an EMC lab. So I've come up with these, what I call thrifty methods to solve a lot of the stuff I worked on. I've worked for about 45 companies over the last, since I retired, 2005. So it's given me a lot of perspective, a lot of sympathy for the product design engineers that have to meet all these standards. Okay, there's also a good book out there. It's one of my references. It's in fact, you give it out sometimes as a gift at some of the EMC shows. The Wyatt book, he's got a real good book on this, but I come up with even cheaper ways to do this. And it's important that you do all this testing up front before the design is frozen, although typically that's when I'm called in. Okay, the first thing I'm going to talk about is these instruments are amazing. What you can get for 140 bucks is Vector Network Analyzer, which I'm going to show the results of later on in the presentation. This thing goes all the way up to 3 gigahertz, and it comes with all the stuff that you see there. You have to calibrate it. It's got the 3 loads there shown. It's got an open, short, and 50 ohm load. And the software is called out there. You just go to that website. It's got tons of information there. So I'm going to use it here for measuring the input impedance and the VSWR, although it can do a lot more. In fact, here's a close-up I took the other day, yesterday, I think it was. This is, it's got a touch screen on it and all kinds of selections. Here's a Smith chart, and you can see it's got a 50 ohm load on it. And it's just, and it indicates just what it should, where 50 ohms is on a Smith chart. But believe me, it has a lot more capability on this. I wanted to give you an example of what it looks like. Again, it's a touch screen. It's very intuitive. It's got a menu on the right side there. So here's another piece of gear I'm going to use. Now, I just found out that you can't get these darn things anymore. It must be on a cargo ship somewhere, because the normal place you get them is Ham Outlet. I think that's what it's called, Ham Outlet, yeah. I went to their site and they don't have them anymore. They have the 2-channel version of it, but they don't have the single-channel version. And I looked on eBay and Amazon, nobody's got them. They warn you on the site there that there's a lot of knockoffs out there. So you got to be careful who you buy them from. If it's too cheap, it's not what you think it is. And I use it with this software called Spectrum Analyzer 1.1. And it has some limitations, but it's still pretty darn impressive. If you go to that website there, it's got just tons of information. It's a bunch of guys in the UK that have made this this is what they do for a living. Here's this is off one of the spec sheets that they have, or one of the manuals they have. And I kind of tripped over this because I thought my spectrum analyzer, this SDR plate, wasn't working right until I read the fine print here. It's very critical how you set the reference level to get a good indication, sensitivity, I should say. And this is a perfect example of it. Plus, now I look at it, it's a good place to show you all the capability of these things. You can see, I don't know, does this show up? Yeah, I guess it does. Anyways, it's got all these spans, they're fixed spans. And that's, if you want to call that a limitation, you got to pick one of them. And it's got a thing here that you got to turn off. It's got whatever it uses inside, it's got this thing that you got to activate to shut off all the harmonics of the microprocessor in there. It works pretty good. So you can see you can set the reference level. It just has amazing a bunch of capability. It takes a while to get used to it, like any instrument, but for 100 and less, well, actually, ham outlet had them on sale for $100 just before Christmas. And all of a sudden they're out of them. So I'm sure it's the same old supply chain thing. They're coming over from the UK. That's where they make them. Here's another one I just added because I use it all the time for personal use. And it's a $60. You can get this on Amazon, a lot of other places. And these radios, as you can see, they're based on a Silicon Labs DSP chipset. And if you want a quick and dirty method of seeing if something's going to cause interference in the AM, FM band, it's also got long wave and short wave, but I normally don't use those. It's got up here, it's got the signal strength and the signal to noise ratio. So what you can do is if you want to evaluate something like from a vehicle or a test setup, just as a quick check, because keep in mind, all these specs are meant to avoid interference with radios. Sometimes we lose track of that. We get so tied up in all the spectrum analyzer Google that we figure you kind of lose track of why you're doing it, all this. So this is kind of a reality check. And there's a couple ways you can use it. You can just put it close to your device under test and see how the signal to noise and the field strength changes as you turn on and off whatever you're testing. Or another simple way, just press one of the buttons here and it'll scan through all the stations. So what you can do is a before and after, like pick up 36 stations before and 20 after you turn on your device. So it's a quick and dirty little gizmo that's really good. And the speakers actually not that bad of quality. I did a little web search on this before I bought it, and it's very sensitive radio. Goes below a microvolt. So that's something that's not in the paper. Oops. Okay, these little things are signal amplifiers. Boy, there's a ton of them on Amazon. What you can do is use it. I got it taken apart here, as you can see. And what's inside of it, you can buy this as a complete unit. It's about $30. Or you can buy the complete unit and put different innards in them, because you can buy the PC board separate for about $10. So I did that just when I was messing around with it. There's a couple different varieties of low noise amplifiers you can put in here. Here's the amplifier there. And it's got all the equipment needed to, all the components to make it work right. Plus it's in a solid aluminum case and it's got a feed through cap on the filter here. Now the way I use it is I just, because it takes about 100 milliamps. So if you work it off a battery, if you're working all day, you're going to keep wearing down your batteries. So I just use a wall charger, which says 12 volts, but they're usually 20 volts out. Then you just put a common IC regulator chip on that to knock the voltage down, put some filtering on it. And that works great. I don't have to worry about battery running down. Okay, you'll see later, for most RE type testing using the temp cell I'm going to show you, one of these is enough, but sometimes you need two. And I'll show you that later. Put two in series to get enough gain. Now again, it's not going to be very flat. The gain kind of goes up and down, but what we're doing in all this testing is comparing results before and after, so it doesn't matter. Here's another thing you use for bulk current injection, which we get into later. I show a quick and dirty way to make one of those. And this one here is only, what was I say here? Yeah, $25. There's a couple modifications you got to make to it because it runs hot as a pistol right out of the box. So there's a ham guy I came across on the web, and he came up with a fix, which is pretty easy. You change the bias on the output FET. Plus I also added some thermal grease because it doesn't come with anything like that. So you just power that up and it's good to go from 200 to 700 megahertz, which is more than enough for do bulk current injection. Here's another little gizmo that we'll be using. It's called the Tiny SA. And again, for $85, you get all this stuff here. Here's the actual unit. It's got a USB cable and some other stuff, other cables. And the thing I'm using it for is a single generator. Because it works very well. If you use the low output, which I'll show you here, it's got two outputs, low and high. If you use the low output, you can get 0.1 to 350 megahertz sine wave out of it. It's unbelievable. And it's pretty pure. I put it on a scope, looked at it, and it's got all kinds of adjustments on it. It's a touch screen, very easy to use. Here's an example. 10 megahertz. Here's the level you can set. You can have modulation if you want it, sweeping, you name it. It's again, it's amazing. $85. I don't know how they make them for that. What else we got here? Okay, so enough of that. Then this Temcell variant, which is really where I started out. Candace wanted me to give a presentation of this, and this whole paper came out of that. Figure if I'm going to all the work to write this up, I might as well go further. So I've used this for quite a while. It's good for checking the radiated emissions of all kinds of things. And it's a variation of a Temcell. I got some pictures coming up. It keeps out a lot of interference, or any interference, AM, FM, you name it, keeps it out. And it's made out of Home Depot special EMC sheet metal. And that's what basically dictated its dimensions. 16 inches is what that stuff comes in. And I show it, let me go ahead. Here's a picture of it with the door. It's just a sliding piece of sheet metal that goes in the grooves here. And it's just a center plate, which I can move up and down. And it goes to, actually this shows with the door on. Actually, I use a big C clamp to do this. But for the picture here, I just put a piece of wood. You got to clamp the top and bottom to make it sealed up. And that keeps everything out. Without that, it lets in some stuff that shouldn't be there. And here's a little door that when I'm trying to evaluate, is the noise coming from the DUT or the wiring, I can put the wiring outside just to kind of see where it's coming from. Here's the internal termination. It just tapers down to a BNC here and a BNC at the other end. The other end, I just put a 50 ohm load on. And here's some of that VNA, vector network analyzer stuff for the Temcell. And you can see it starts going really ratty above about 200 megahertz or so, somewhere in this area. And this is, what's this? This is impedance, and this is standing wave ratio on the right side. Again, this is all using the Sabre software, which is free on their website for this VNA. And you can see again over a couple hundred megahertz, it kind of goes crazy. But it's still useful. I use it in the gigahertz range, and it's still useful. And I had, I don't know if you know the guy, Ken Kaiser. He actually reviewed this paper and said, as long as you're just comparing results, that's okay. I don't know, he wrote a big, oh God, a 1,200 page book, EMC handbook. He's at a local EMC lab just on Northville Road by my house. And I just stopped by and he gave me a lot of good information for this report. So even though this shows that it normally wouldn't be used over a couple hundred megahertz, you can still use it because you're just comparing results with and without fixes. Let's see, did I forget anything? This pretty much says what I've been saying.
Arnie, can you talk about that RF amplifier that you said got real hot? Is that what you're driving the Temcell with?
No, the Temcell's for radiated emissions. This is for bulk current, which is coming up.
Okay. Okay, maybe you can talk about power level maybe that you get from that amplifier.
Yeah, you don't need much.
You don't need
This
much.
is good. I think it's advertised for, can't remember, a couple watts.
A couple watts, okay.
That's all you need.
Yeah. Okay.
So that's the temp cell. Bulk current injection. Now this is kind of interesting. Again, I do everything on the cheap. And let me show you the picture here. I got this from the one of the references in the report. It's not in the paper for incompliance, but this is from the paper. This is what told me how these probes are made. They just got a single turn on them. I was surprised to see that. So here's my version of it, just using copper tape, going to a BNC connector. And here's some, oops. Yeah, and this gives the particular one I use, particular ferrite clamp. What else we got here? So I have a setup here. Here's some actual measurements into that probe with the VNA again. This is for a single turn. And this is where for a two turn, just two turns, widely spaced apart. So there wasn't much capacitive coupling. So it looks like one turn is all you can take on this. Look at the scale difference. Here it's 110 max S11, and VSR goes up to about 2.11, I think. Yeah. And with two turns, it goes nuts. So this kind of tells you that one turn is all you can get away with. That's why it's made like that. So that was kind of a learning experience for me, actually. Here's the setup I use to see how much current you can get out of this current clamp, BCI clamp. So what I'm doing there is I'm taking my signal generator, feeding into this power amp, going to a, I think that's a 3 dB pad. Yeah. And this, then it goes to the current probe, of course, current clamp. And here's the calibration fixture. Of course, the ones you see that you buy commercially are a lot more fancy than this. But all this is 50 ohms here and a 10 dB attenuator there. It goes to my spectrum analyzer. And that's where I learned that you can get 100 milliamps out of this guy over a pretty broad frequency range. So this compares with a lot more expensive stuff. Now here's something I thought would be interesting. I've seen it in books, and I used to use it before. This little piezoelectric barbecue lighter. You can get a spark out of it. It doesn't show the ground side, but you usually have a wire attached to this. You have to take it apart and make it like it is here. So I thought this would be good, but I remember in a lab, I can't remember the guy's name, but he allowed me to actually put this on a Pellegrini target. We were just standing there. I said, do you mind if I put this on there? And there's just no energy in it at all. It didn't even register on the scope. So you pretty much have to use the real McCoy if you want anything close to what an ESD event should be. So does this look familiar, Scott?
Yes, I remember that. I haven't seen it in a few years, but I do remember that. That came from one of our labs. I don't remember if it was in Mexico. I think it was in Georgia. I think we had a lab in Georgia briefly. So then it came back to Canton, but the network in it wasn't for automotive, as I recall. It was for IEC, right? It's not the automotive 2000 ohm network. So we couldn't really use it. So I heard Arnie was looking for something, so he was the lucky guy to get it.
Yeah, you made a bill of sale and everything. Most companies don't want to go to all that bother, but
yeah,
thank you. And so we're going to use that in an example to follow. So it says there's no cheap way to really do it right. Although this looked appealing. You got a spark out of it, but there's no energy in there, or very little. Here's some examples. This is this shows an inverter, and here's a wiring harness. Here's the load, a light bulb, the battery to run it all. And this is how it's normally set up. Normally you can fit all the stuff in there. And if you can't fit it in, you can raise the center plate there to make more room. Again, you're just looking for A, B. You're not looking to anything to meet a spec or anything like that. So here's the results before, and here's the results after. And it didn't meet the official automotive spec before, but it did after. So there's a lot of correlation here directionally. So that worked pretty good. And here's another thing I worked on. It's a very complex module. It's got 10G. It's an Ethernet switch is what it is. And it was a real challenge. And I worked on this for quite a while before I came up with a fix. And you can see the before and after. And this is in the gigahertz range, which the TEM cell is still working with. So it works to a pretty high range, even though theoretically it shouldn't. And the results are very noticeable. So here's another one. This was a actual field issue. And it was a, actually it was a taillight assembly. Yeah, it's this at the top. And it was causing some trouble light to come on in the dash. They couldn't figure it out. So I thought it was probably transients like it usually is. So I used the ones in this standard I wrote some years back. It basically is the Ford chatter relay type transients. And there's a paper that talks about it. It's one of the references written by Keith Fraser and his companion, I forget his name, Allies, I think it was, Allies. They're very realistic but severe. It's not like the ISO transients, which don't tell you anything. In fact, the next paper to come out of me is talks about that. That these ISO transients are very repeatable, but they don't tell you, they don't uncover any real field issues. They're just really repeatable, but they're so common, it's hard to take it out of specs. But Ford does, and I think it's in the latest version of the ISO one. They finally got it in there. So what the culprit was ESD. And boy, I burned up dozens of these boards figuring this out. Here's the IC, that's the suspect. And you have to zap each pin one at a time. And I found that one of the pins, there was a big difference. Mostly the pins will take greater than 6 kV, multiple discharges, no malfunctions. But this one pin was less than 2 kV, one discharge, and it was gone. So here's where you need an accurate ESD gun. It's a piezoelectric glider won't do it for you here. So once you found that, we just put a cap on there and the problem went away.
So Arnie, when it was having the field failure, was it catastrophic or was it something?
No, it was a, well, what do you call it? Nuisance. A light on the dash would come on.
But you couldn't make you couldn't repeat the nuisance?
Pardon?
You couldn't make the nuisance, you couldn't make a nuisance with your simulator to simulate the field?
Well, I just found that IC had a weak pin on it,
Yeah.
which we fixed. They implemented, and the problem went away on the car.
Oh, okay, gotcha.
So this is just one part of the tail light. There's a bunch of other stuff, but this was the part of it that had the problem. So that was a real head scratcher for a long time until we finally figured this out. Now here's some good references I was telling you about. Here's that one by Ken. Here's where I got that current probe information from, got me in the right direction. It's the only paper I've ever seen that showed the innards of one of those BCI probes. And here's a paper I wrote some years ago, characterization, conductive immunity. It's got a bunch of stuff in it about characterizing, like the name implies or says. what the conductive immunity of a product is. So it goes further than just the ISO stuff and the Ford transients. It does design margins and other stuff. We used to do a lot of that in Visteon to see how robust our products are. Because one of the things that's not in this paper is when you look at a lot of OEMs, the ones over here in the US, pretty much, Chrysler, GM, Ford, they're just meeting spec, not just for EMC, but other things, shake and bake and all that. But when you actually go to, I used to do this with Visteon, they send me to Toyota or Nissan or Hyundai. You look at what they're actually doing on a daily basis, and it's not what's in the spec. They're finding design margins. In fact, when you're standing in front of a thermal chamber, you say, those aren't the temperatures that are in the spec. And they'll say, well, aren't you doing design margins? No. Well, that's a general statement. Some guys do. Some engineers do more of that than others, but usually under the pressure of everything that's going on, they're just meeting a spec and move on to something else. That's the name guy. Sharon, Keith wrote a good paper on those ISO transients. That was quite a while ago. And it's taken Keith, through his efforts, a lot of effort to get them put in the 7637 standard. They just don't like the fact that it's not repeatable. The results are very repeatable, but the actual transients are very random in nature, which is what you want to find real world problems. Those repeatable results are not going to find a lot of problems. But when you get a random series of events, it lines up with certain points in software execution, and all of a sudden you see stuff you'll never see with the ISO transient. So this is a good paper about that. So that's a lot of stuff. Let's see if I forgot anything. Talked about all
While
that.
you're searching through there, we have a couple comments in the chat window. One is,
Good.
you need to update the slide. It's $3,300 a day for ALSE chamber. RI 114 will give you super shock. $3,300 a day.
Yeah, you're right. Yeah, you're right.
Yeah, I didn't know it was that high. I mean, that is getting astronomical.
That's crazy. I don't know how. Yeah, you're right.
You might be able to get a plumber for less than that. I don't know.
That's a real old number. It's what I came to the top of my head. It's probably 10 years old.
Well, I remember it used to be 2,000 a day, and then I've heard 3,000 a day, but I guess it's even gone beyond that now. It also depends on if you're using microwaves, if you're using real high field levels, you know, if you need a really big chamber for a vehicle, or you're just doing components. So there's a lot of factors there. Yeah.
Yeah, I don't know how you, I see all the time I spend fixing some of these things. Some are a lot easier to fix than others. Some you can literally spend a month on. Now I'm down in my basement. I got a lab with all this stuff, and I'm working a lot more hours than what I charge. I do this, don't laugh, it's kind of a hobby. It keeps me busy. You know, you stop, you die. That's the theory.
Right.
So I do this as a hobby, and the money's nice, and I just enjoy doing it. It's kind of fun.
Hey, that RF amplifier that you showed, where did you get that from?
I think it was right off Amazon. It's amazing.
Oh.
Most of the stuff like that, the RF amplifier, this.
Oh, no, I was thinking of the other one, but yeah, both of those. The case, did it come with the case, or
no,
the case is separate?
It doesn't have one. There's probably.
I mean, the other one you showed, the low signal amplifier.
Yeah, this one you can buy them just the plain board. It's got a little different connector here in the end. But you want this whole thing, you know, you're at very low levels for this TEM cell, what it puts out. So you want to put it in a box So this is a good way to do it. So I bought this, then I bought some of these different varieties of them just to try them out. Actually, I didn't see any difference at all on the results.
But you can get that case separately from Amazon?
No, you have to buy the whole unit.
Oh,
It'll
okay.
come with one of these PC boards in it. I forget which one.
Got it.
But there's 5-volt versions, there's 12-volt versions. There's standard ICs that are in them. In fact, this
Yeah,
particular,
I have one of these. I bought the same thing. It was like $19. And I figured, well, you know, the other amplifier in the preceding slide, that also was from Amazon, you think? Oh,
yeah,
maybe
that's
that was not
what-
it. That one, yeah.
Now, I had to make that change because it does get hot. It'll burn up on you. I don't know why they sell them like that.
Is the
Which
bottom of that
basically-
a heat sink? The whole bottom of that assembly a heat sink?
Yeah,
Is that what we see?
yeah, but I put some thermal grease in it because I figured that would help.
Sure.
That's before I realized that, again, you do a web search and these ham guys do a lot of this stuff. And that's how he fixed it. It basically changes the bias on the MOSFET.
Okay.
So I don't know if you can see it on this one. Is this one of the units? Can't see it.
Probably the reason that it is biased that high is for linearity in digital television signals.
Oh, I knew there had to be a reason, but in fact, some of the comments you read on it says the darn thing burns right up.
Wow.
So, I don't know why they just didn't make this change. It's not a drastic change. You're going from 5K to 3.3. It just
Yeah.
happens to be what I have laying around. And you could feel the difference right away.
Nice.
So that's all it takes to do bulk current, just a watt or so. So I was surprised. I never pay much attention to that. You just go to an EMC lab and they just make it work.
I just looked this up on Amazon. I don't see it there.
Oh, I don't know where else I would have got it from.
NWSZ-RF-PA, I didn't see it. Maybe they stopped selling it.
That could be, just like that RSP1A, that SDR play. I can't find them anywhere. They're just sold out. But they'll.
Well, there's another one. There's another one available. It's not as good as that. I got both of those. Both that one and this other one is called RTL-SDR dongle.
Yeah, there's other ones, but this software, it was pretty nice to use. And once you get used to it, it takes days to get really comfortable with it. And once I uncovered all of its, all the things you had to learn about it, because it's got a lot of capability. And again, I ordered a second one because I thought the first one was, where is that? I thought the first one was broken. In other words, I overstressed it until I know this is verboten in engineer world, but I read the actual manual. That's where I came across this. It says its sensitivity is highly dependent on where you set the reference level. Just dawned on me. How stupid can you be? So this is right out of the manual.
Yeah, as far as I know, there's a couple newer versions of the SDR Play, which I don't know if they're suitable for what you're trying to do. I think the big thing, the reason why you can't really use an RTL SDR or something like that is because you need, a lot of those, they stop working down below 70 megahertz and you need to go, it looks like you're needing to go down to 2 or lower. And the only other thing I can think of that would do that is like a hack RF.
Well, this thing will go down. Normally this comes with a thing called SDR Uno. That's really what it's for. That's the radio part of it, which is a whole different thing. This goes down to, I forget the range, but it's very low. That's when I didn't put it in there.
Okay.
Really,
Actually, I have one of those as well.
Yeah, it goes down to kilohertz, I think. It's a very wide range. Well, here it is. Let's see, span. Yeah, it gets down to kilohertz. I forget the numbers. It's all on the website.
Yeah, the other good thing about the SDR Play, unlike a lot of the other SDRs, this one has like switchable filtering in different bands. So
Yeah, it's got a
Yeah.
table in there for all that. It's amazing. I don't know what the chipset they use because you can't quite make it out. If you open up the box, it's got some kind of a shielding coating inside. The more expensive 2-channel one, I think, is a metal box. That's like $250. So I guess you can still get that from Ham Outlet. That's the official thing. If you go to their website here, that's the people they tell you to buy it from. Apparently, there's a lot of knockoffs, although I didn't see anything on. Again,
Well,
I
they're the
couldn't
company
find it.
that makes it. So they're like you can buy these things from like Ham Radio Outlet. They're like an authorized distributor. There's probably
Yeah, but
other
they're out of
Giga
these.
parts.
They're out of these. Again, they were on sale for $100 before the holidays. Then all of a sudden they don't have them. And I
Well,
looked at,
that's the world we live in now.
yeah, they're on a cargo ship somewhere.
Yep.
We have a comment. This says Great Scott Gadgets has the hack RF SDR that does receive to 6 gigahertz and transmit at a low power. It's other SDR. It's other SDR. This is many things on Amazon have changed names over time. Amazon has random supplier names.
Yeah,
If I find, and the items are available if you hunt. So that was from Malcolm Lunn.
yeah. If they're too cheap, don't buy it.
Yeah,
It's a knockoff.
okay.
And the website spends, of course, they're selling them, but the guys in the UK there, they got a staff of people on a bunch of YouTube videos on it. They keep warning you about not buying a knockoff. Of course, you would expect them to say that, but
Then we have a question from Akio to John Suriano. Is this the ESD gun, the same one that you made? So John, can you comment on that?
yeah, this is the one I made. I was actually using it for years. And again, when you're in EMC labs, you jump on the opportunity, and we were standing there doing something. And I said, can I try this gun? I've always been curious to see what it really puts out. And he had it all set up there. He had a very high frequency scope, gigahertz scope, the target. And I put it on there and we couldn't even get a reading. It was so low. I
Yeah.
tried to look for the data and in my records, although I keep a lot of stuff, I just couldn't find it. So I had to go from memory.
Mhm.
Yeah, we made an ESD gun, but it was a different principle. It used a transformer from a TV set,
Oh,
had
okay.
capacitors in it, and we charged it up using
Oh, yeah.
transients, and then had a relay to.
Well, you know, again, I'm writing another paper. Actually, it's about the history of the EMC specs for one major auto company, which you can guess which one it is. But I spent some time talking about the ESD thing, and I remember we're going through all the experiments and why it's not repeatable. Doing a lot of searching. Everything is important when you're doing ESD testing. That's when I see test results and I know how unrepeatable this stuff is unless you control a lot of parameters. We even had a fixture when I was at Visteon to control the approach speed, because that all matters.
Yeah.
It just, everything matters when you're doing that test. And I go to labs and I see these guys just not controlling a lot of parameters, shall we say.
Mhm.
So when you get non-repeatable results, there's always reasons. That's why these specs are getting so long, because you gotta write everything down or it doesn't get done. And even when you write it down, sometimes it doesn't get done.
Mhm.
So most of these specs are all those details. Otherwise, you could just call out ISO such and such. But there's a lot of details that aren't in those standards. Okay.
Okay. Any more questions for Arnie?
If you have any
Ever
questions,
find,
just send me an email.
Ever find a good cheap solder station?
No, I got a Weller. That was for Christmas present though.
Just a plain
I forget
old.
the number of it. It's a nice one. You could control the temperature and all kinds of stuff
Oh.
on it. And they're not expensive. They're $100 or something like that. It's not worth messing around with these really cheap ones. I should mention, this is the, this was quite a project here. This is the one they put on the F-150s and a lot of other vehicles. It's not the big one. If you know, I worked on that one too. I think it's kilowatts, many kilowatts. It's the one you see on the news all the time. Man, that's dangerous to work on. You got to watch what you touch. So I got a couple. This was no big deal. It's just lower power. But the big one that they put on the F-150s, man, that'll give you a jolt.
Wow.
Arnie, I thought the F-150 with the 7 kilowatt, that actually comes off the transmission. It's not a,
Well, the one I was working on, I might have misquoted the vehicle. I thought it was an F-150, but it's driven off a separate alternator. So it's a lot of power.
yeah. Question for you on that static gun. It's a one shot pulse, if I'm understanding correctly. Is that correct, the way that gun works?
Well, you can set it up for various modes. The actual, the commercial gun.
Yes, the one that you made is also, you call that
Oh,
commercial?
well, that's another part of the variability. You're getting more than one spark. It looks like just one, but it's really more. It's kind of like chattering relay. Well, that's not a good example. I'll take that back. Yeah, it's more than one. It's highly variable, but there's no energy there at all. Very little. It'll get a spark, but it's not much energy.
Okay.
So from the chat window, Malcolm says some F-150 with high power inverter has 2 alternators.
2, wow. Well, I mostly worked on this lower one and just looked at the other one, and we did some tests. Actually, there's you find these test labs all over the place. There's one right off US 23.
Yeah, in Brighton.
Amphenol. And
Oh.
down in the basement, there is a screen room from World War II. They got a parts bin. It looked like you're in World War II stuff.
Wow.
And it's actually, they use it to do some outside. They do some 10-meter testing for vehicles. You'd never guess it was there. It was a restaurant at one time.
Yeah, I know the one. Just south of Lee Road.
Yeah, that's the one.
Yeah. That used to be
Amphenol.
Willow Run Test Labs in Ypsilanti, and they moved up there.
Oh, okay.
That's the same group. That's Val Lipa was associated with them too.
Yeah, in fact, he came down in the basement one day and said, "Wow, Val, never seen you in a long time."
Yeah, right. Yeah. Did he have his dog with him?
No.
He used to bring some dogs over at Willow Run. You'd see dogs over there.
Well, Willow Run was, that's an old one. They used to have a horsehair anechoic chamber.
Yeah.
Can you believe that? Horsehair?
No, when I saw it maybe 10 years ago, and it looked like polyurethane when I was there.
No, this was a long time ago.
Yeah. Is any more questions? If not, we'll move on to the drawing. Okay. So I used random.org to come up with a random number list for tonight, and you must be present to win. We're going to start with the $25 gift card from Amazon. The first random number is 36. So number 36 is Matt Mejkowski. Matt, are you still on the line? So
I'm here.
Okay, excellent. You've won
Excellent.
$25 gift card.
I can almost afford an RF amplifier now.
That's right. So I've got Matt Majkowski at msn.com. That's correct?
That is correct.
Okay, congratulations.
Why, thank you.
So next we're going to draw for a $50 Amazon card. And that is number 45. 45 is Daniel Wow. Daniel, are you here? M-O-U-W.
Yes, I'm still on.
Okay, excellent. So your email is dmouw25@gmail.com.
Correct.
Okay, excellent. Well, we've never had 2 in a row, I don't think, in all of our history. Everybody, okay, next is $75 to number 55. And that is Jack Riddle. Jack, are you still here?
Yes, I am. And,
Wow.
well,
First time this has ever happened.
thank you.
Sometimes this takes 10 minutes to get through this.
Thanks very much.
So I've got jackriddle2@gmail.com.
That's right.
Okay, excellent. Well, thanks, everybody. If there's no further questions, I'm going to stop the recording.
I do have one
Thank
question.
you.
Okay, go ahead with your question.
Arnie, are you familiar with Latinx test equipment, spectrum analyzers and so forth? I think they're sold by EMC Shielding. They're relatively low cost. I wonder if you had any experience.
No, no. What's
Okay.
it called?
LATNEX,
LAVEX?
Lima Alpha Tango, November Echo X-ray.
Oh, slow down. Lima-
LATNEX.
LATEX?
LATNEX.
Oh, no, I never heard of them.
They're like under $200 spectrum analyzers, come with cases and everything,
Oh,
and
well,
RF generators.
well, that, yeah, I'll have to look them, LATMEX.
November N.
I'll get it eventually. LATNEX.
Yep.
Oh, finally. $200. Well, that's pretty high. I don't know.
Yeah, I know.
It's, yeah.
I just
most of
posted
it-
a link in the chat.
Yeah, he posted the link in the chat if you want to look at that.
Yeah, I looked at the webpage and this reminds me, are these the RF Explorers?
Yes.
Yeah, they look like it. Okay. Yeah, I know people have used these. I don't have one myself. I've got a tiny SA at home, and then I've got all kinds of really cool stuff at work.
Well, you know, with this stuff so cheap, it opens up to a lot of possibilities to do things you wouldn't normally think of doing.
Oh, agreed. My days of like I got a Nano VNA as well. I got the deluxe version in the metal case, the one that goes up to 3 gigahertz. So my days of like hand tuning antennas using a homemade SWR bridge is over. I just use the VNA to do it.
Yeah, it's amazing all the stuff. It takes a while to learn all its capabilities. And even that spectrum analyzer, I call out the SDR play. It takes a while just to get comfortable with it. You say, is that right? Is that right? I don't know. Then you do some experiments to see if it all lines up. Like you take the signal generator there, and then you put it into through some attenuators into the SDR play, and so yeah, it's pretty darn accurate. But it's all because of all these chipsets that are out there make it possible.
Yeah, a lot of these are they were originally developed for like doing digital TV stuff.
Oh, is that right?
Yeah, they use that's where, like the original, the RTL SDR dongle came from. That was like a design that was used for DVB-T sticks for Europe. And then somebody discovered that, oh, well, this is really internally, it's kind of a software defined radio. All this is just basically down convert and then generate, and then you stick an A to D converter on the other end and you get IQ samples out. And then you just do demodulation or whatever in software. And then somebody learned, well, we can use this for all kinds of things.
Well, I see this. I was looking at the chat notes here. It says one F-150 with high power inverter or 2 alternators. That's what I meant. It was an extra alternator. Is that what you meant?
Yeah.
Yeah, okay, yeah, right. It has a separate alternator just for that. I don't know how they squeeze it all in there, but they do. That one was actually made by another company. The company I work for made the panel on the rear in the, what do you call it, the pickup part of the truck?
The bed.
Yeah, the bed. So I was trying to think. They actually make that part. The actual thing I think is made by Delta, if I remember right. Okay.
I'm gonna stop the recording now, but you guys feel free to keep networking and chatting. I'm gonna stop the recording.